Game is played with an ordinary fair six-sided die. A player throws the die once. If the result is 2, 3, 4, or 5, that result is the player's score and the player does not throw the die again. If the result is 1 or 6, the player throws the die a second time and the player's score is the sum of the two numbers from the two throws. Part A. Draw a fully labeled tree diagram to represent this information. Okay, so we'll have 1 or 2 or 3 or 4, 5 or 6. On each throw, the probability of each throw will be 1/6. Since this is a dice throw. Okay, so if 1 or 6 is thrown, then you get another throw. So we're going to write 1 or 2, 3, 4, 5, and 6. Each of these will have a probability of 1/6 again. And similarly, 1, 2, 3, 4, 5, and 6. Okay. So each of these probability is going to be 1/6 as well. Okay, I'm out of space, so I'm not writing it, but you will write it. Okay, so part A is done. Event A and B are defined as follows. Event A, the player's score is 5, 6, 7, 8, or 9. Okay, so I'm going to write all the scores here as well next to it. So 1 and 1 gives a score of 2. So let's write 2 here. Then 1 and 2 gives a score of 3. 1 and 3 gives a score of 4, 5, 6, and 7. The score is still 2 for this one, 3, 4, 5. And here the score will be 7, 8, 9, 10, 11, and 12. Okay. So event A is that the score is 5, 6, 7, 8, or 9. Let me highlight that. 5, 6, 7, 5, 6, 7, 8, and 9. So these are all event A. And event B is that the player has two throws. Okay, so let's highlight all the event B's as well. So we get two throws in all of these 6 cases and 2 throws for all of these 6 cases. Okay, so show that probability of event A is 1/3. All right, so event A is when the score is 5. And how do you get a 5? By throwing 1 and 4. That has a probability of 1/6 times 1/6. So 1/6 into 1/6. Okay. Similarly, we get a score of 6 by throwing 1 and 5. That also has a probability of 1/6, 1/6 times 1/6. Then event A also includes 7, which we obtain by getting 1 and then 6, which has a probability of 1/6, 1/6. Similarly, for this 7, for this 8, and for this 9, the probability is 1/6 into 1/6. So there are actually 6 1/6 times 1/6. Plus, we will also include this 5 here, which is obtained by throwing a 5, and the probability of throwing a 5 is 1/6. Add all of these together, multiply and add all of these, and you will get 1/3, which is the probability of event A. Okay. Part C, determine whether or not events A and B are independent. Okay, so if independent, then probability of A intersection B will be equals to probability of A times probability of B. Okay, so we already have probability of A, which is 1/3. Let's calculate probability of B. B is obtained, event B is that the player has two throws. So two throws is, for example, Here, when you get 1 and 1, then you get 1 and 2, then you get 1 and 3, 1 and 4, 1 and 5, 1 and 6. So that's again 1 by 6 into 1 by 6 for each of these cases. 1 by 6 into 1 by 6. And how many such cases are there? Um, 1, 2, 3, 4, 5, 6 here and 6 here. 1, 2, 3, 4, 5, 6. So we multiply this with 12 and let's see what we get. So 12 into 1 by 6 into 1 by 6. So that's also 1/3. Okay. Now we're going to find probability of A and B, both of them happening together. That's these three cases and these three cases. So probability of A and B is 6 times 1 by 6 into 1 by 6, which is 1 by 6. So, is 1 by 6 equals to probability of A times probability of B? No, it's not. 1 by 6 is not equals to 1 by 9, hence not independent. Okay. Part C is done. Find A given B, find B given A complement. Okay, so we have to find B given A complement. So that would be probability B and A complement, the conditional probability formula over probability of A complement. Okay, A complement means not A. So if we have the probability of A, which is 1 by 3, then probability of not A will be 1 minus 1 over 3. So the denominator will be 1 minus 1 over 3. Okay. And the numerator is B and A complement. So that would be this case, because this is not A, but it is B. There are two throws here. So event B is happening and the result is the score is neither 5, 6, 7, 8 or 9, none of those. So B and not A includes this score, this score, this score, and this, and this. So there are 6 of those cases. 6 into probability of each of these cases, 1 by 6 into 1 by 6. Okay, let's see that what that gets us. So numerator is 6 into 1 by 6 into 1 by 6. Denominator is 1 minus 1/3, which is going to be 1 by 4.